Welcome back. We're on lesson 19 of Precalculus, Properties of Logarithms, Chapter 3, Section 3 in a book by Larson. What we're going to learn today is how to rewrite logarithms using different bases, use properties of logarithms to evaluate, which means find a number and answer, or to rewrite logarithmic expressions, use properties of logarithms to expand or condense logarithmic expressions, use logarithmic functions to model and solve real-life problems. All right, so first of all, we have this antiquated change of base formula, which you really don't need anymore. But we'll go ahead and say what it is. So if you have a log to the base a of x, you can rewrite it as the log base b of x over the log base b of a. Let me just do an example for you. So if you got the log base 5 of 8, the old calculators couldn't find that answer. So it would come in handy to use the change of base formula, and you could do the log 8 over the log of 5. Again, if it's not written down, you know that it's to the base 10. Or let me do it again. If you have the log base 3 of 6, you can do the log of 6 divided by the log of 3. Again, that would be to the base 10. It's just assuming that something is to the base 10. If they don't put a base on it, it's to the base 10. But like I told you guys, you have this new function feature in your calculators. It does a change of base for you. So you hit the math key, and you go down, and you get log base. And you can put that base 9 in there, 4. And so log base 9 of 4 is equal to 0.631 when you round it to 3 decimal places. If you don't have the newer calculator, then you're going to have to use that change of base formula and do the log of 4 divided by the log of 9, and you get the same answer. So the next one here, hit math. I'm going to go all the way down to the base thing. Log base 1/8 of 64, you get negative 2. On the next page, we have some rules that you need to memorize for logs. They do come in handy. You should know them all. You won't find them, the formulas, on the formula page for the ACT or SAT test. I don't remember if the ACT gives you any formulas. I don't think it really does. The SAT gives you some formulas, but they're area formulas, so that won't come in handy. But it comes in handy to know these, and you'll see the log questions about what to do with logs on those both of those tests. And anyway, it helps to know them. So the first property is if you are multiplying two quantities together, if you're taking the log of two quantities multiplied together, you're allowed to pull them apart and add them. If you're dividing two quantities by a log, you can pull them apart and subtract them. If it's to a power, you're allowed to put it in front and do n times the log base a of u. Same thing with natural logs. It's all the same rules. We talked about this. The natural log is just the log to the base e. So they just rewrite it to make it fancy and say natural log of x. So all the same rules for logs apply to natural logs. There's no difference between logs and natural logs other than the base is e on it. So it says on the next one, rewrite the expression in terms of the natural log of 4 and the natural log of 5. So this is a fun thing to do. So we want everything to say a 4 or a 5 on it. So let's break the number 500 down. We'll make a factor tree. 5 times 100, 4 times 100, 4 times 25, and that's 5 times 5. So we can rewrite natural log of 500 is 3 5s and 4 2s. So rewriting it in terms of just the 5 and the 4. We don't want a 3 or a 2 because they want it in terms of just the natural log of 4 and the natural log of 5. So we have these two quantities multiplied together. So by the product property up above, when you're multiplying two quantities together and taking the log of it, you're allowed to pull them apart and add them. So I can rewrite that as the log of 5 to the third plus the log of 4 to the second. and by the power property, I can pull the power in front of it. So that would make 3 log 5. Oh, they were natural logs, weren't they? That's a sad story. So 3 natural log of 5 plus 2 natural log of 4. Again, log, natural log, whatever. So you can rewrite it like that. Then on the next one, it's the same thing again. They want it in terms of the number 4 and the number 5. It's division, so we're going to change that to subtraction. So that makes the natural log of 5 minus the natural log of 2. So we have 5, but this isn't a 4, so we need to make it into a 4. So to make that into 4 from the number 2, so natural log of 5 minus the natural log of 4, it's the same thing as saying the square root of 4, or 4 to the 1/2. The square root of 4 is 2. So I'm going to pull that power in front, so then we have the natural log of 5 minus 1/2 the natural log of 4. And that would be the answer to the whole thing. Okay, on the next one, it wants us to graph them with any base. It says use the change of base formula and the graphing utility to graph the function. So again, if you don't have a newer calculator, you're going to write the log of x plus 2 divided by the log of 1/3. But again, most of us have the newer calculator, so let's just use it. So y equals, so math, go all the way down to log base. So I have a log base 1/3, and it's x plus 2. Graph. All right, so it appears like there's nothing there, like it's going into nowhere. No, don't do that to me. No. Because of the plus 2 and it's inside with the x, that made it a horizontal shift to the left 2. So instead of having the asymptote, the vertical asymptote of x equals 0, instead it's going to be x equals -2. That's the vertical asymptote. And let's go ahead and get some numbers off of here. So second table, at -1 it's 0. At 1 it's -1. And then they get smaller, but they just keep going. There's no asymptote here horizontally. It just always keeps getting slower. Again, it's getting slower, it's getting smaller very slowly, but it's getting smaller. So it's going down to -infinity. It's just not doing it fast. It's still infinite to -infinity. There's no speed on infinity. It's going to get there eventually, and there's no ending to infinity, so I guess there's no rush to get there. The domain on this is the fun one to do. The domain starts from the left, again, small or large. It starts from the left at -2, and it goes to infinity. The range is infinite. It goes all the way down to up. So -infinity to infinity. Honestly, it's not that much fun to do the rest of them. We'll do one more of them. We'll do 36. So on 36, we have back to y equals. We can just write over that. Look, it's still 1/3. And they have x divided by 3. There we go. So the asymptote on this one, since there's nothing added to the x at all, the asymptote on this is what it's supposed to be. There was no shift in it. It's x equals 0. And again, getting some numbers from the table for fun. At 1, it's 1. At 2, it's very small. At 3, it's 0. That's fun. That's useful. And then it gets smaller, but not fast. But it's going again forever to -infinity, just not fast. Again, there's no place to go, so why hurry? So the domain's the fun one on this. The domain, again, starting from the left to the right, it's from 0 to infinity. And the range on it, though, is infinite. So starting from the bottom and up, -infinity to infinity. All right. On the next page, it says simplifying logarithms. Use properties of logarithms to rewrite and simplify the logarithmic expression. So we have a multiply, And this they're taking the log of all of this. I know maybe a parenthesis might have been helpful, but they're doing the log of all of it. And it's multiplied, so we're adding. So log base 3 of 9 to the second plus log base 3 of 2 to the fourth. And then by the power property, you can pull this out front. So it's 2 log base 3 of 3, 9. It's a 9. So 2 log base 3 of 9 plus log base 4 log base 3 of 2. I'm making a mess. Well, now you got to sit here and look at the numbers. The 3 and the 2, we can't make those the same. But looking over here at the 9 and the 3, oh yeah, we can do something with that. The 9 is 3 squared. So I'll rewrite that. I'll do it nicer. I'm getting kind of sloppy here. So 2 log base 3 of 3 squared plus then 4 times log base 3 of 2. Again, by the power property, I can pull that in front and multiply by what, if there's something in front, just multiply by it. So that makes 4 log base 3 of 3. So by the properties of logs that we learned in the last section before this one, look at that. It's 1. So that's 4 times 1 or 4 plus 4 log base 3 of 2. So kind of fun. All right, so the next one, it's another multiplying one. On the next one, it's 8 times e to the third. So again, we can add them. So it's the natural log of 8 plus the natural log of e to the third. So I'm going to put the 3 in front. So it's a natural log of 8 plus 3 natural log of e. Again, the natural log is to the base e. We just don't write it. So we have an e and an e. So just like above here, 3 and a 3 is a 1, e and e, that's 1. So that just makes the natural log of 8 plus 3. Okay, on the next one, it's division. So that would be subtraction. So we got the natural log of e to the fifth minus the natural log of 7. I'm going to put the 5 in front. So 5 natural log of e minus the natural log of 7. Again, that's gone. So it's 5 minus the natural log of 7. All right, on the next one, we're going to expand them, which is kind of what we've been doing already. So expanding them, it's multiplied, so we're going to add them. So it's a log base 10 of 100 plus log base 10 times of x. And again, eyeball it now. Look at that. We can make that a 10. So that would make that log base 10 of 10 squared. And you can pull the 2 in front then. So you got 2 log base 10 of 10. That's gone because of the 10 and the 10. So the whole answer then is 2 plus the log base 10 of x. Okay, on the next one, this one isn't that much fun. All you can do is put the negative 3 in front. So negative 3 log base 6 of z. And that's it. We're done. Well, we got more on the next page. So on the next page, on number 58, we have 3 quantities multiplied together. Log base 4 of x times y to the 6 times z to the fourth. You can pull all those apart and add them up. So that's a log base 4 of x plus the log base 4 of y to the 6 plus log base 4 of z to the fourth. So the only other thing then we could do is pull the numbers in front by the power property. So we have the log base 4 of x plus 6 times log base 4 of y plus 4 log base 4 of z. Okay, on the next one, it's division. So when you're doing division, it's subtraction. So that changes it to natural log of x minus the natural log of, I'm just going to go ahead and rewrite it. It's x squared plus 1 to the 1/2. Whenever you're doing the square root, notice the word square. Square is 2. So it's to the 1/2. So I'm going to pull that in front. So it's the natural log of x minus 1/2 natural log of x squared plus 1. And that's all you can do on it. There's nothing else you can do to it. because some of the kids were trying to pull the 2 out and multiply by it. No, because the whole thing isn't to the second power. If all of it was to the second power, then you could multiply by it. But that doesn't work. Okay, on the next one, we're going the other way now. We're condensing it. We expanded it before, now we're going to condense it. So go backwards. So the first one is subtraction. When it's subtraction, it's division. So it's 8 divided by t. That's it. The next one, we're going to put the power over here. So it's log base 7 of z minus 4 to the 5 over 2. That's all we can do. We can just move that. Okay, on the next one, I'm going to go ahead and move that 2 right there because it's the power of it. And we're subtracting, so that's division. So it's the natural log of x divided by x, well, the natural log of x plus 2 squared. No, that's about it. That's all you can do to it. But I could write it nicer, huh? That's really sloppy. I feel better now. I know you do too. All right, so that's it, I think, right? Yep. All right, I'll see you for the next lesson.